On the surface, a company's data pipelines might appear to be working perfectly. Batch jobs run, data gets processed, and reports get generated. But beneath this apparent success are hidden risks that can cost companies millions in just a few seconds. And it doesn't start with dramatic failures. Often it happens silently when a single piece of data falls out of sync with reality. To understand how this happens, I want you to imagine an online retailer that built its reputation on the promise of next day delivery. To achieve this, they've constructed a robust logistics platform. However, an element of the design doesn't match with the reality of the business, and this creates a challenge. The issue lives in a single piece of legacy code, a batch update. Batch updates are a common and accepted practice in the world of data engineering, and yet, many businesses are moving away from them. For example, Walmart operated for years on a batch-based inventory system before they made a well-documented transition to a real-time event streaming architecture. So if batch updates are so common, why are companies like Walmart moving away from them? Imagine our online retailer has just launched a new smartphone that costs $1,000. It's a hot item and there's a lot of demand for it. At 9:01 a.m., the last phone is sold from the inventory. Unfortunately, the inventory of the product is managed by a separate system from the sales. The two are kept in sync by a batch update that runs every hour. This means the sales platform won't receive inventory updates for at least 59 minutes. Our data is now stale, and the company will be making decisions based on information that is fundamentally wrong. Meanwhile, the website keeps on working, confidently accepting hundreds or even thousands of new orders for a smartphone that no longer exists in the warehouse. At $1,000 per transaction, this adds up quickly. And worse, it's attaching the guaranteed next day delivery promise to every one of them. Then at 10 a.m., the batch job runs, the system sees the truth, and everything erupts into chaos. But is that an exaggeration? How much damage can a 59-minute delay really cause? Well, in an extreme example, we could look at the issues Ticketmaster had during the Taylor Swift Eras tour. 3.5 million fans registered for the presale, creating what Ticketmaster themselves called historically unprecedented demand. Of course, these days everything is labeled unprecedented, so who really knows anymore? Anyway, fans who had put tickets in their shopping carts discovered that they weren't actually available when they went to check out. The seat inventory wasn't matching the reality. In the end, the load on the system proved to be too much and the entire thing crashed, forcing Ticketmaster to halt the presale. The fallout was massive, with congressional hearings, antitrust investigations, and lawsuits that are still ongoing. I'm dramatically simplifying the details of what happened behind the scenes in this case. We don't actually know if the inventory mismatches were caused by batch processing, concurrency issues, or something else. The point isn't what caused the mismatch, but rather to illustrate that what seems like a small, inconsequential problem can become extreme when operating at scale. So now our online retailer has hundreds of broken promises to deal with. Maybe they can reroute orders from warehouses on the other side of the country, but that's not going to be cheap or fast. Suddenly, the next day delivery has become 3-day delivery, and people lose trust in the guarantee. The defining feature of the business is now a liability. And think about this. All of that chaos, financial loss, and brand damage wasn't caused by a major system crash or a cyber attack. It was caused by a simple mismatch between expectation and reality. The customer's expectation was that they would purchase a new smartphone in real time and have it delivered the next day. The reality is that what they see on the website is potentially 59 minutes out of date. So how can we ensure that the system matches the real world? To answer this, I like to use something called Klang's conjecture. Victor Klang, one of the creators of akka, said that if you cannot solve a problem without programming, you cannot solve it with programming. I like this quote. It encourages us to take a look at the business domain in the absence of software. This can help us better understand the problem as it exists in the real world. So let's do that. Imagine our customer is buying their smartphone from a physical store. As they browse the shelves in the store, they locate the product they want, take it off the shelf, and put it in their shopping cart. Then they walk up to the counter where they pay for it. These actions represent events in our business domain. An event is a thing that happened in the past, and each of these events happens in real time as the customer interacts with the store. The problems occur when we take these real time events and put artificial constraints on them. Imagine, for example, if customers could only place items in their cart once per hour on the hour. This might sound absurd, but bear with me for a moment. Customers would find the item they want, but they can't take it off the shelf until the top of the hour, so they wander around waiting. When the time comes, several customers rush to put the same item in their cart, and if the stock is insufficient, fights might break out. We've created a door crasher sale that's all crash and no sale. This is essentially what happens when we introduce a batch process. We're taking real time events and artificially constraining them to be processed at certain times of the day. However, this constraint only exists in the software. It serves no purpose in the real business domain. So, why do we do it? Despite how it seems, introducing these artificial batches wasn't always a bad idea. In the early days, software was there to augment humans. Customers were interacting with physical objects, and they can see visually whether an item is in stock or not. If the computer disagrees with what's on the shelf, then we don't worry about it because we trust our eyes. However, in today's world, the software is often the only thing the customer interacts with, and we no longer have the luxury of interacting directly with the physical products. If the software tells us one thing, but the reality is something else, we have no way to reconcile the differences. So while batch jobs were effective in a human-centric world, they begin to break down in a software-centric one. This is why businesses are increasingly turning to stream processing to solve their biggest problems. The core idea is that instead of accumulating data in artificial batches and processing them later, we organize it into real-time data streams. Then we process the events in the streams as they happen. This preserves the real-time event-driven state of the business and eliminates stale data. This creates interesting opportunities for the modern data engineer. Traditionally, data engineers have focused on building batch pipelines to consume operational data and produce analytical tables that can be used to help with decision making. However, as software moves toward real-time stream processing, the role of the data engineer is evolving. In recent years, the work that was traditionally done with batch jobs in data lakes or warehouses has been shifting upstream toward real-time operational event streams. This approach has become known as shift-left analytics, or sometimes just shift-left, and refers to moving critical processes earlier in the pipeline. The idea is to move the processing of the data upstream closer to its source. We take the logic of cleaning, validating, and transforming the data and perform all of those operations in stream. The shift-left approach delivers three key benefits. First, the latency for data to become available is dramatically reduced. It's available immediately instead of waiting for scheduled batch windows. Second, the reliability improves. A failed process can pick up where it left off rather than being forced to restart an entire batch job. Third, it eliminates duplication by creating reusable data products. This is a great alternative to cleaning, validating, and transforming data across multiple batch jobs. This is the future of the data engineer. Data engineers are learning to adapt to this new world of streaming. In essence, they're becoming data stream engineers. The traditional role of the data engineer was building batch jobs to produce analytics tables. The future role of the data stream engineer will be building real-time data products to be consumed not just in the analytical space, but in the operational space as well. Now let's circle back to our original story and see how we would solve it using data stream engineering. At 9:01 a.m., when our final gadget was sold, a product sold event would have been published to a data stream. The inventory management system would subscribe to these events and update the inventory numbers accordingly. Once the stock on our smartphone reaches zero, a product sold out event could be published back into our event streaming platform. This event could be picked up by the website, which would immediately stop allowing customers to purchase the item. Instead of waiting an hour for the updates to occur, we've reduced the delay to mere moments. The exact amount of time varies depending on the streaming platform, but it's often a few hundred milliseconds or less, which means we've solved our problem before it ever arose. And we didn't do it by introducing a convoluted or complex process. We did it by modeling the actual events that happen in the system in real time, so it reflects the reality of the business rather than introducing artificial constraints. This illustrates the paradigm shift that is happening today. Batch processing and traditional data engineering, while valuable in the past, have always worked against the real time flow of events. Stream processing and data stream engineering embrace that natural flow. They allow us to build systems that are more responsive, more reliable, and ultimately more aligned with the true nature of the business. As businesses continue to evolve, especially in the rise of AI, these real time streams will become increasingly important. Batch may become a thing of the past, but that doesn't mean the role of the data engineer has to go with it.